In this section of the lesson, we are going to do a bit of cleanup for our animations so that we're showing the correct animation when the player is firing, and then we'll start to work on enemies. So right now inside the game up to this point, we can move around, we can jump, we can land. We're showing all the right animations for just regular movement, but you'll notice if we now fire off when he's standing still with the idle, it looks okay, but if we're walking, it kind of looks weird, right? And if we're jumping, it actually will probably look okay. So we want to update the images when the player is walking left and right and firing. Let's go back into our player object, into the step event, which we seem to be using for everything. In order to show the correct version of the sprites, if the player is firing their weapon, you'll need to make sure that you have brought in all of the player sprites, which we've done previously, because we're going to make use of the remaining player sprites at this point. So if I come into my animations, let me expand this out so we can see things a little bit better. And let's zoom in a little here. Okay. So where do we want to update this? If I come down, here is where the player is up in the air and we're showing one of the jumping animations, and those are actually fine. We don't need to mess with those. However, when the player is down on the ground, here's where we want to update things. If they're not moving, right now we're just showing the idle animation, and if they are moving, we're showing the walking animation. Well, let's take into account in this section if the player is firing their weapon and then alter the sprite dependent on that. So let's start first. If the player is not moving, then let's do another if check to see if they're firing. And the way we can do that is we can say key shoot, right? So if key shoot, meaning if key shoot is true, then what do we want to do? Then we're going to set the sprite index equals to the sprite that we use for them shooting if they're standing still, which is the one that's called sPlayer SS. And sPlayer SS is just a single image just standing with the gun pointing out. All right. Else, meaning that they're not shooting, but they are standing still, then we'll use the sprite we've been using already, the idle animation. Right. So we do the same thing now. If they are moving, in fact, I'm going to steal all of this code. If they are moving, and if they are trying to shoot, then we'll set the sprite index to sPlayer S, which is this sprite where they're walking along with the gun pointed out. Else, we'll use the regular old walking sprite. Okay, so it's just coming into each of these movement animations and updating them so that now we can detect if they are moving or not. Let's check that out. So here's our player. Now if I press the fire button, you'll see he switches to the standing fire. If I'm going left and right, then he switches to the walking and firing animation, which is what we want. Excellent. All right, so that's it in terms of setting up our animations for our player. In fact, I think we now have officially hit all of the animations. So let's move on now and begin to create the bad guys inside our game. So I'll close down my player step event and close down the player. We're going to leave the player for a moment. To begin to work with the bad guys, the enemies inside the game, we need to bring in their sprites. Let's save time again by going into the resources folder and bringing in all of the necessary sprites for this. So here we are inside the resources folder from the Blackboard site. We already brought in all the sounds, and we already brought in all the player sprites and the tile set. Now we're going to bring in 3, or I guess I should say 4 enemy sprites. Do I need all of those? That seems like more than I need. Just a moment, let me see. Let me double check if we really need all of these. Yeah, I guess we do. Alright, so let's bring in all of the enemy sprites, just select them all, then drag them up into Game Maker in the workspace, and then let's go through each of them and get them set up appropriately so that they'll work right. Alright, let's start with our S enemy sprite. It's a single sprite, which is just the enemy standing still. The only thing we need to do for this one is to set the origin to the middle center. And I guess there's one more thing we need to do. We need to mess with the collision mask like we did with the player. So let's open up the collision mask, shrink him down so we can see him a little. I'm going to change from automatic mode to manual mode. We'll leave the type as rectangle, and then let's adjust this a little bit. I set it on my machine to the left to 18, the top to 14, the right to 29, and I left the bottom at 47. And you can see that that just sort of gives us this little center spot here to use for collisions. And that should work all right. Excellent. All right, let's close that guy down. And let's go to our next one. We've got, let's do senemy r4 underscore strip 4. Get rid of the underscore strip 4 so that we're going to call this sprite senemy r for running. We're sort of matching the same naming scheme we did for the player. Let's switch the origin to the middle center, and then we'll take care of the collision mask later on when we set up the enemy object, so we don't have to worry about that here. So we'll close that one out. And what else have we got? We have our senemy a underscore strip 2. Get rid of the underscore strip 2 and set the origin point here as well to middle center, and we'll take care of collision mask later. And finally we have senemy d underscore strip 2. Get rid of the underscore strip 2. Change the origin to middle center. And we'll not worry about the collision mask for this one either. Alright, so now we've got our sprites all set up for our enemy objects. So let's create, we're actually going to have 2 enemy objects, but we'll start with the main one. So resources, create object, create yourself an enemy object. This will be O enemy. And we will give the sprite as senemy, will be our default sprite. And then as we did with the player, we want all of our different enemy sprites to use the same collision mask. So under collision mask, switch from same as sprite by clicking this down arrow and specifically choose senemy. Then no matter which sprite we swap into this object, they'll all use the senemy collision mask. Alright. Now we're going to set up our enemy object in a slightly different way than what we did for the player. If I go back to the player for a second here, you can see that on the player we had a create event, and in the create event we established a collection of variables that we wanted to use for our player. We could do the exact same thing for our enemy object, but I want to show you a different approach to establishing variables for an object. And this is new to newer versions of Game Maker, and this approach I'm going to show you has some advantages. It's not 100% necessary for the project we're doing, but I want to show you just a cool approach that you can use. So for our enemy object, instead of doing a create event and then listing out all the variables we want, here on the enemy object, I'm going to come down to this menu item here called Variable Definitions. I'll click on that. It'll open up a little window in here, and then I can start adding in variables that I want to use for this object. So we're doing sort of the same thing, right? So we're going to have a VSP. We'll set the speed to 0. Let's add another one. We're going to have gravity on our player. We'll set that equal to 0.34, same as we did with our player. We're going to have a walk speed, just like we did with our player, and we'll set it to 3, so it's going to be a little slower than our player's walk speed. We're going to have horizontal speed, just like we did with our player, and we're going to do this slightly different. I'm going to set the horizontal speed equal to, this is going to be confusing, the walk speed. So I've set the walk speed to 3, then I'm going to set the horizontal speed to whatever the walk speed is, which is initialized to 3. And I think it'll actually probably stay 3, except occasionally we update this to be something different, right? We set it up to be a 1 if we're getting close to a wall. So far, these are all similar to what we did with our player. Let's give some different ones here, though. For our enemies, we're going to have hit points. So I'm going to set hit points. I'm going to start them off at 4, meaning that we have to hit this enemy 4 times to knock it out. Then I'm going to have another variable called hit from, and set this to 1. We're going to use this to help determine whether the enemy gets hit from the left or from the right, and then depending on the direction from which the enemy gets hit, we're going to have it sort of bounce in the opposite direction. And then we're going to do one more in here, which we're going to just say is size. We're going to create our own instance variable called size. We'll set that to 1, which is going to mean 100%. We'll use this later on in order to create a bigger version of our default enemy. All right, so that's it. So make sure you have all those in there. You can pause the video and type all those in. And then once you've got them in, restart the video and we'll continue on. So close that off. So now we have established a collection of instance variables doing this new approach instead of the create event. So we don't need a create event now for our enemy. Instead, we'll just start off with the step event. And our step event for our enemy object is going to do a lot of stuff. In fact, it's going to operate, at least in part, like the step event in our player, except now we're going to be working on enemy movement. And all our enemies are going to do in this game is move. They're not going to do anything else. Right? So how do we want our enemies to be able to move? Well, they are going to function, as I said, a lot like how our player functioned in terms of movement. And so, in fact, what we can do is go back into our player, into the player step event, go into the collisions and movement section, and we are going to borrow all the stuff we wrote for horizontal collisions and movement, and all the stuff that we wrote for vertical collisions and movement. We don't need jumping. So I'm going to copy that and then come back to our enemy into its step event, and I'm going to paste it all in. Now it's not going to work exactly the same, because with our well, it's going to come quite close. With our player, what we did was, if you remember, if we were approaching a wall going left or right, we would just keep moving until we hit that wall, and then we would stop moving. With our enemies, though, what we want to do is if we are about to run into a wall, so you can use the exact same code, we will approach it just like we did before, and we don't want to stop if we hit a wall. Because if we did, imagine how this would work. The player would walk along, it would come up against a wall, and then it would just stop. Well, that's not very interesting. We want our player instead to come up until it reaches a wall, and then we want it to reverse direction and go the opposite way. So for our player, we set the horizontal speed equal to 0. Here what we're going to do is, if they run up against the wall, we're going to set the horizontal speed equal to negative horizontal speed, which will have the effect of reversing direction. So it'll come up to a wall, come right up to the wall, and then it will turn around and go the other direction. And then we have to actually make it move. So we'll add the horizontal speed to the x coordinate of the enemy, which means if we're moving along, it'll just keep moving to the right, and then it'll hit a wall, and then it will start moving to the left. So if we do the vertical collision, it's going to function in a very similar way, except for our vertical collision, because we're on a platformer and there's gravity in our platformer, we don't need our enemy to reverse direction. It, in fact, will function exactly the same way as the vertical collision did for our player. The only thing that's missing here is that we need to actually update the y position. So we'll say y, we'll add to it, plus equals our vertical speed. So if we're jumping in the air, let's say, except our player can't jump, but it can drop off of a platform, right? So it can be walking along, walk off the edge of a platform, and then drop until it hits one of our wall objects, and then we want its vertical movement to stop. So what else is missing in here? Well, there is one thing that's missing that we did in our player that we also need to do inside our enemy, and that is, if you remember, inside our enemy, every single step, inside our player, every single step, no matter what was happening, we needed to apply gravity to our player. Similarly, we need to apply gravity to our enemy. So we'll set the vertical speed every single step in the game equal to our vertical speed plus gravity. Gravity is always taking hold. Apply gravity. Right? And you'll note I've written this out the long way. You can do that if you want. You can also do it the short way, which is to say vertical speed plus equals gravity. That will take whatever the value of vertical speed is, and it will add gravity to that value. Okay. All right. That will take care of movement, but it won't take care of any of the animations. But let's stop here for a moment and just see what we've got so far. So let's go into our room. And inside my room, I'm trying to be careful about managing all of the objects that I'm placing out in the room by using layers over here. So let's do the same thing here. I'm going to select the walls layer and create a new instance layer, so it'll be right above the wall in terms of its drawing. And we'll rename that. Let's call it enemy. And with the enemy layer selected, let's grab our little enemy object and drop it over here near the player. And let's see what this looks like. So here's our little enemy. He hits the wall, turns around, goes the other direction, hits the wall, turns around, goes the other direction. Sweet. So he's doing what he's supposed to do in terms of movement. But obviously the animations aren't set up correctly, so let's go back to our enemy and deal with the animations. So here too, we will be able to make use of the animation code that we had for our player. So let's, we're in the step event. Why don't we do this? Let's create a region here. And come down to the end of that section and say end region, like so. And that will allow us to shrink that down. Let's give it a name. We'll call it collisions and movement. Close it down. Come afterward, let's create a new region. And that will be for animations. Do an end region. Okay. All right, so I could copy and paste in the existing animation code from the player, but we actually do a lot more with the animation in the player because we have so many different states for our player than we do for our enemy. So I might as well just type it in and join with me. All right. So first we're going to check if the player is up in the air. Let's take care of that. So just the same way we did with our player, now we're going to do with our enemy. So we'll say if not, place meeting x, y plus 1 is going to look 1 pixel below us for a wall object. All right, so if we're not on the ground, that means we are in the air. So we need to show the in the air version of our enemy sprite. So we'll say sprite index equals s enemy a, which is our in the air enemy sprite. And exactly like our player, it has 2 frames, and when we're moving upward we want to show the upward version of the flying enemy, and we're moving downward we want to show the downward version of the flying enemy, and we don't want our enemy sprite to animate. So this is all exactly the same as what we did for the player. So first we need to set the image speed equal to 0. That will stop our enemy animation from animating. Then we're going to check if we're going up or down using sign, and we're going to say if the sign of the vertical speed is greater than 0, what does that mean? That means that we're falling down toward the ground. Then we will set the image index equal to 1, which is the second frame in our in the air enemy sprite. Else image index equals 0, which is the first frame, frame 0. Okay, so if we're falling down toward the ground, meaning our vertical speed is greater than 0, we'll set the second image as the one we want. Otherwise it means we're going up in the air, which I'm not sure can ever actually happen. Then we'll show image index 0, right, just to be safe. We'll do it that way. Okay. So that all takes care of things if we are up in the air. What do we do if we're not up in the air? Well, we can say else we're not up in the air. So let's set the right animation or the right sprites for when the enemy is not in the air. First of all, we need to make sure that we're actually animating again, just like we did with our player. So we'll set the image speed equals to 1. That's full speed animation. Then we want to see, is the enemy standing still? So we'll check if their horizontal speed is equal to 0, meaning they're not moving. Then we'll set the sprite index equal to s enemy. In fact, we're only doing one thing, so I'm going to simplify my code a little bit here, just like we did here. Okay, so if they're not moving, the horizontal speed is 0, then we'll set the sprite index equal to s enemy. Else we'll set the sprite index equal to s enemy r, which is our walking version of our enemy sprite. Let me expand this out a little bit. It's giving an error because we got this extra squiggly brace here that we don't need. Cleaning things up a little bit here. All right, so one more time. If the player's in the air, show the in the air sprite. Set the image speed to 0 to stop it animating. Check that the player's falling downwards. If so, show the second sub-image in our sprite. Otherwise, show the first sub-image in the sprite. Else, meaning on the ground, in the air, if they're on the ground, let the image animate again. If they're not moving, set the sprite to our enemy sprite. If they are moving, else, set the sprite to the walking enemy animation. All right, so that's should look familiar because it's very much like what we did with our player. Okay. And as we did with our player, at the very end, we want to make sure that we are having our enemy facing to the right if they're moving right, and facing to the left if they are facing to the left. All right, so just like we did in our player, first we want to check if they're moving. So if their horizontal speed is not equal to 0, that means they're moving. Then we'll set the image X scale equal to the sine of our horizontal speed, which will be 1 if we're going to the right, -1 if we're going to the left. Right to this point, this is what we had with the player. We're going to add one extra piece to the enemy. If you remember back when we were setting up our enemy, if I close out of this step event, one of the variables we set up at the very beginning was size, and we set it to 1. So in the step event, when we are animating our enemy, I want to make sure that we take into account the size variable, meaning basically the size of our enemy. And I can do that here. So when I'm setting the image X scale, I want to make sure it's facing the right direction, but I also want to make sure it's the correct size. So I can take the image X scale equal to 1 or -1 times size. And right now, size is 1, so it's just going to be 1 or -1. But imagine we create a different version of our enemy that's bigger. Maybe it's 2. So then it would be, X scale would be 2 or -2. Well, once we start taking this into account, okay, show left or right, correct size. Okay. Once we take into account size, if we're doing it on the X scale, we had better do it on the Y scale also. Now we don't care, there's no left or right for the Y scale here, but we do need to take it into account. So we'll say image Y scale equals size. So if the Y scale is, if the size is 1, which it is now, that's no problem. We haven't had to do this before because our size has always been 1, so we've never had to worry about the Y scale. But if it were 2 and we didn't update this, we would have an enemy object that looked really fat, real wide, but not real tall. So we need to make sure that we update both of these. Okay, that was a whole lot of work. Let's see what that looks like. Okay, here's our enemy. He's walking that way, he's walking that way, so hooray! He's doing just what he's supposed to do. He turns around and faces the correct direction. Let me show you what would happen while we're here. If I come back into the enemy and go down to the size variable that we set at the beginning, and let's set this now to something ridiculous, like 3. Because we're now taking this size variable into account, now, good lord, he loses his mind. Oh, okay. You can see he's huge, and he's got some other issues going on, so we'd have to play around a little bit with that. But you can see we now have this much larger guy. If you want to know why he's running into that weird issue where he doesn't look quite right, the reason is once we resized him, he's now in the ground. So pull them up. Let's put them up over here. And now he walks along quite happily till he drops down in there, and then he gets stuck and goes back and forth. Pretty cool, huh? To wrap up this section, let me talk a little bit more about why we set things up this way, using variable definitions for our player instead of doing them in a create event. I'm going to set our size back to 1. Okay. And I'm going to come back out into our room, and I'm on my enemy layer, and I've got my enemy. Now his size is back to 1. We'll put one of them here. I'm going to come over and grab another one and drop them off over into this section. I'll put them up in the air a little bit. Now watch this. If I select this guy out in the room, and I then double click on him, it's a little hard to see. Let me zoom in on this guy. Come on, zoom in. There we go. All right, so I've pulled out an instance of our enemy object and placed him out into the room, and then I've double clicked on him. And when I do that, you'll see now it's giving me information about this specific copy. Here's the unique ID that we've been using in other projects before now. Now you can see that each instance of our enemy has its own unique identifier. And you'll see now, hey, here's this section called variables. And here are all those variables that I set. So if I want to change a variable just for this guy, I can click on this little pencil, and let's say I want this guy to be size 2. That will change that size variable just for that copy of the enemy. So now if I play, you'll see now we've got one copy that's a small size, we got the other copy that is this bigger size. Let's do one more. Grab another guy, put him way out up here, double click, and there we go. Come to the size, and we'll update the size here as well. Let's say, well, let's make this guy really big. 5. It's going to be a huge. Well, in fact, he may be so huge that he might be stuck in the ground. Let's take a look. No, all right, he's not. Good Lord, now I got this humongous enemy walking out in the room. And because we also set our hit points inside these variables, you could then pull out different instances of your enemies, modify the size of a specific instance of the enemy here, and then also modify the hit points. Let's say you want to ultimately have to fire on a big enemy more times in order to knock it out, then you could do that here. Now, of course, there are other ways to do this. We could have created a script and then called the script and passed it information. We've done that in other projects. But this is a nice quick way to make the same thing happen.